So you know, when we started Cognite 6 years ago, we have this vision about fully automating industry. And we were very naive, like I'm sure you can confirm, that we thought we could just bring AI, and like Guy was saying, it's not that easy. So we needed to fix the data problem, but still our vision is the same. We really want to fully automate the whole of industry. With generative AI and large language models, we are getting one super important piece. And that's what I'm going to talk about today. So the vision is this: we want to automate everything, but how can you get to this? So you know, Cognite has been running robots for a long time. We use the robots to get more information about the asset. So what is the current condition? Does it leak? Has the leak stopped? Do we have corrosion? Is people wearing helmets, like was shown here before? And then we feed back into the twin in real-time view of what's happening. Then again, we take that to plan the next robot mission. So this is a continuous cycle. Do a lot of different things with this. So for instance, go and scan areas. We can do 360 images, we can recreate the 3D model, you can see all kinds of defects, a lot of different things. But we don't want to just read, we want to also touch valves. We want to scrape on corrosion to see if it's worse than just surface corrosion. So we need to get better robots as well. So we need humanoids, that's robots that look like you and me, because everything has been designed for people. Like all the gauges, all the signs, all the doors, all the elevators, all the stairs, ladders, everything has been designed for a human. What we need is what I talked about before. We need something that's able to capture what the humans are doing and learn from that so that we can actually replay that. And exactly like, you know, the large language model, how they have been trained to learn language, we are learning how to turn valves, how to walk, all of these things. And so the Boston Dynamics robot, it's just calculating at the moment. The same thing with Spot, you've seen our yellow robot dog. It's just calculating. It's doing this super quickly, like 1,500 times per second. But it's not learning at all. If this robot falls down the staircase, it will do that every time. We have been working quite a lot with learning different types of models on our computer vision, so we can recognize all kinds of defects, like cracks, corrosion, all of these different types of things. But we have not been teaching the robots what to do yet. We are now starting to train the robots to learn from people on the sites. So if you want to turn a valve and close that, a human is going to come and hold and touch the robot to learn how to close this valve. And it's going to learn this, and the feeling and the forces on the motors and everything like that is going to be stored in that same vector space as with the large language models. So when you're saying close this valve tightly, that is motor torques, which is stored in the same space, multidimensional space, as the word vectors for that particular sentence, like close this valve tightly. So what you're saying here is that these robots, they will need to train on a lot of data. They will need to get a lot of information from people on how to do things. And this is what we're getting with the large language models as well. So you know, the large language models, they now get access to everything here. You can ask any kind of questions, ask the robot to do any kind of action here. But also, we have humans, and we're sort of sucking up what they're doing in the field. What are they looking at? How are they diagnosing? And this all goes back to the robots. I think what we're actually doing is that we're copying humans, and now we're copying the brain of humans. If you look at this chart of sort of the functions of the brain and what we have been able to mimic, I think all of these are now starting to get to green. You know, we are training a lot of these sensory things. We can see corrosion, we can read gauges, we can see spills, leaks. So actually the sensory systems of the robots are already superhuman to sort of this brain. we're using the large language models together with other kinds of machine learning models, in this case a visual model, in a multi-model fashion. So again, you don't retrain your large language model, you just take that and in the same vector space, in those same dimensions, you pull in features from images. We also train machine learning models to recognize components in space. So here we recognize the valves, the tanks, the pumps, everything. So we don't need a lot of ground truth data, rather we just scan the site, recognize all the components, and then you start using that. Like here I can go and say, do a visual inspection of all my pumps. You don't need any other data than just the robots. Now this is an example of teaching the robots. So I just want to show this because this shows sort of the progress of this now. When this robot, its task is to learn to walk. And it uses 60 minutes to learn to walk from no examples whatsoever. Like we will be using people to show the robot what to do. But in this case, we just give it a goal and it learns all this by itself. I think one of the really key, very interesting things here is that you see this robot turns over on its stomach, just like my kids. Then it starts to try to push up, and then it goes a little backwards and forwards, exactly like my kids again. And then, after 60 minutes, it is a super robust walker. So here, in this case, you see the guy pushing it over, and super quick back on its feet. You can see that it's even planning how to get up as it's falling. Like, as you're falling, you're planning a way to get up back up again, really quickly. And this is with no example, but we have a lot of workers out in the sites that can show examples, and this is an example of that. So if I want to turn a valve, I'm just going to take the arms of the robot. They are compliant, so they will follow my lead. Pull the sort of the valve by holding their hands, exactly like this guy is doing. So he's taking a robot, he's flipping it like a backflip, and then he wants the robot to learn how to do this itself. Now, we run this through simulation for the robot to figure out and not have to train in the real world. And then the robot learns how to do backflip in simulation, less than a day, less than 1 day. And then we try to reapply to real. And this can be, the sim to real chasm can be difficult to leap over. But look at this. The robot is able to get back up on its back feet, flip over, and do the backflip. So teaching by example, I think is going to be super important for industry. You all have aging workers that have a lot of domain knowledge about how to run your plants. But they will be able to give this knowledge to robots, and we can copy as many of the robots as we want. We used to need to have very, very high-cost robots, but here you can see a super low-cost robot that is getting really good at walking and playing football in this case. It's super low-cost. These are just super hobby servos, it's super simple things, but by learning, they are getting really good. You see, they don't fall over, they're really good at sort of moving around. So scaling with robots, I think again something magical with robots. If one robot has learned to walk, they all know how to walk. If you have 1,000 robots, they all know how to do this. If one of your workers train this robot to close the valve, they all know how to close this valve. So it scales really well. What this means is that, to me now, I know this sounds a little bit like high level, but to me, I don't see a missing puzzle piece currently. We have a way to be hands-on site with robots. We have a way to capture domain knowledge from the existing workers. And we have a way to communicate with the system on a level where anybody can speak to the system, like absolutely everybody. So let's go build it.